Utilizing biomanipulation through the addition of zooplankton to prevent algal blooms. As a background, over the past 50 years, nitrates and phosphates have polluted bodies of water, leading to harmful algal blooms that deplete the surrounding water of dissolved oxygen. There have been recent findings utilizing biomanipulation to increase the population of zooplankton and consume the excess algae. Lake Lanier, a local lake, has had an excess number of algae in the Flat Creek area due to sewage and fertilizer runoff. This experiment collected samples from the Flat Creek area and the Chattahoochee area to control the population of microalgae. These samples were taken from two different locations, and in the Chattahoochee River, it had a lower concentration of algae. The dissolved oxygen and chlorophyll A concentration were measured after each addition of Cladocera zooplankton. When the zooplankton consumed the excess algae, they were expected to decrease and stabilize as a population. This was expected to lead to an increase in the production of dissolved oxygen since they are photosynthetic organisms. From each location, there were two containers with added fertilizer to symbolize the excess nutrients. Overall, this experiment was in aim to prevent the formation of harmful algal blooms. So the hypothesis was, if an adequate amount of Cladocera zooplankton was added to a body of water with excess algal growth, the chlorophyll A concentration will decrease below 10 micrograms per liter, therefore increasing the concentration of dissolved oxygen above 5 milligrams per liter. The chlorophyll A levels were analyzed with spectrophotometer analysis and then plugged into the equation. The dissolved oxygen concentrations were measured with the dissolved oxygen testing kit. These were the microscope samples, and as seen, Flat Creek showed a distinct greenish tinge compared to the Chattahoochee River. With the initial dissolved oxygen levels, Flat Creek showed a significantly lower amount of dissolved oxygen. The concentrations then increased after 2 milliliters of Cladocera zooplankton had been added. The sample with added fertilizer decreased entirely in dissolved oxygen due to cellular respiration and excess nutrients. Over a total of 2 milliliters of zooplankton was added. This caused the sample with zooplankton to increase 380% after 2 milliliters was added. Therefore, this concentration of zooplankton was effective in increasing the dissolved oxygen. The same was shown for the percent change of Flat Creek. Over time, dissolved oxygen changed the greatest with the fertilizer and zooplankton sample and decreased the most after 1 milliliter of zooplankton, but it increased the most after 2 milliliters were added, with just the Cladocera zooplankton sample. There were differences in the initial chlorophyll levels before zooplankton had been added. Therefore, the percent change was mainly analyzed. 1 milliliter of zooplankton decreased the algae the most, but 2 milliliters barely had an effect on the concentrations as seen with the zooplankton sample and the regular sample without any zooplankton. They were about the same. This was also seen with the percent change. It did not affect the algal growth. Comparing the river with a lower amount of algae, after 1 milliliter of Cladocera zooplankton, the regular sample increased the greatest due to its regular concentration of phytoplankton. This was the percent change of the chlorophyll A in just the Cladocera zooplankton. And as seen in both the Chattahoochee and the Flat Creek, the chlorophyll A concentration increased in the end. Analyzing the data compared to the tested samples by the Chattahoochee River keepers who collected their data from UGA, my samples were higher than the actual chlorophyll A values of 6.91 micrograms per liter due to errors with the spectrophotometer analysis. After adding 1 milliliter of zooplankton, the value spiked to an average of 79.774 micrograms per liter due to errors in equipment, which was seen here on these graphs. The percent growth after 1 milliliter of zooplankton from Flat Creek showed that the algal growth decreased in just the zooplankton sample, since it increased the least of 271%, which was according to the expected outcomes. After 2 milliliters of zooplankton in Flat Creek, the sample with only zooplankton increased 134% in chlorophyll content overall, which was 1% more than the regular controlled samples. These were not according to the predicted outcomes. Regarding dissolved oxygen, the initial values showed a sufficient amount of oxygen for most species. After 1 milliliter of zooplankton was added, they decreased below 3 milligrams per liter, which is stressful to most aquatic species. Analyzing the percent change after 1 milliliter of zooplankton showed the similar results of a decrease in dissolved oxygen. After 2 milliliters of zooplankton was added, the dissolved oxygen actually increased, as seen with the percent change from Flat Creek and the Chattahoochee River. After 2 milliliters of zooplankton was added, the dissolved oxygen increased, which was according to expected outcomes. There were errors in the procedure with the change in equipment of the spectrophotometer after the initial values, which resulted in the significant increase in chlorophyll. There was also the confounding variable of a contained environment, so it would have had a much different effect if added to the larger bodies of water. In conclusion, the addition of 1 milliliters of zooplankton caused the chlorophyll concentration to increase, which was due to errors in experimental methods. Overall, 1 milliliter of Cladocera zooplankton was effective in reducing algal growth, but it was not enough to increase the dissolved oxygen and sustain life. Therefore, another milliliter of Cladocera zooplankton was added to the samples, which decreased the average chlorophyll concentration. From Flat Creek, it decreased the concentration 134%, which was 1% more than the regular sample. Therefore, the added milliliter had little effect on the algal growth. So overall, 2 milliliters of zooplankton was an effective amount of primary consumers to sustain aquatic life, but it did not overall decrease the algal growth compared to the control. 1 milliliter of zooplankton was most effective in decreasing the algal growth, but it did not really help the dissolved oxygen levels. So the hypothesis was partially supported. Overall, the first milliliter of zooplankton caused the algal growth to decrease the most. In the future, a better method of analyzing the chlorophyll A concentration can be done utilizing a sonicator to better perform the cell lysis process and a more advanced spectrophotometer to accurately measure the precise chlorophyll A levels. These samples can also be measured in a more controlled environment to determine the most precise algal biomass. In the future, as this method of biomanipulation is more tested, it can actually decrease the formation of harmful algal blooms that have polluted many bodies of water, such as the Mediterranean Sea. Thank you.